In example 1, the relationship of volume in terms of pressure is examined. If the students in the chemistry lab were asked instead to explore the relationship of pressure in terms of volume, what mathematical model could be written to predict the pressure if the volume were 7 and 3/10 milliliters? Draw a diagram to describe the relationship and explain it in words. Make a scatter plot with the dataset in the table. Write and graph a function to model the dataset. Analyze the reasonableness of the model, and compare the domain and range of the function and the dataset. Then compare the mathematical domain and range of the function model to the reasonable domain and range for which the function model is the data. Okay, so let's first just describe the relationship between the volume and pressure. And so notice here that as the volume increases, as it goes from around 4 to 9, then the pressure decreases because it's going from around 29 and it keeps decreasing all the way down to 15. And so to draw a diagram, then we can just use arrows here and say, well, as the volume increases, then the pressure decreases. And vice versa, as the pressure increases, then the volume decreases. And so to say that in words, we can just say when the volume increases, then the pressure decreases. And when the pressure increases, the volume decreases. So now let's make a scatter plot with the data set in the table. And so let's go to our stat menu in our calculator, and then in L1, let's put in our values for volume. And then in L2, let's put in our volumes for pressure, and then we'll make our scatter plot. Okay, and so going into our stat edit, pressing enter, then you can go ahead and enter into list 1 our volume values, and then list 2 our pressure, and then go to second stat plot and just make sure that your plot 1 is on. You can press enter there, and then just make sure it's on and has the marks. I just put it as a standard square mark, and then you can go ahead and press graph, and we see all of our values here. Just make sure that your window is correct. So I have a window going from 0 to 12 on the X values and then 0 to 70 on the Y. And so, just make sure that you're able to see all of your values. And so let's keep going. And so now we need to actually find our function to represent our scatter plot. And so because this is an inverse relationship between volume and pressure, and because the products of V and P look fairly similar, we can go ahead and take the average of these products and then use that to make a rational function. And so to find the average, we'll just add these products and then divide by 5, the number that there are. And so adding together the products of V and P, then we get 657 and 2/10. And then dividing that by 5, then we get 131 and 44/100. And so now we can write our equation, and it says here the relationship of pressure in terms of volume. And so in terms of volume means that the volume will be the independent variable. And so we can write P of V, so pressure in terms of volume, equals, and then our average of the products divided by V. And so now let's graph our function model and see if it matches our data set. Okay, so putting in our function into y1, then we have 131 and 44/100 divided by x, our independent. I just put x instead of v, since our x value is also list 1 here, and so that should match our scatter plot x value. And so let's go ahead and press graph. And so we see here that the function model does go very close or right in the middle of all of our values, and so it's a great and accurate model according to the data that we have. So let's go ahead and continue. Okay, now that we've done that, let's go ahead and find the domain and range of our function model, and then we'll compare that with the domain and range of our data set. I'll just say D for domain here. And so for our V, volume, what numbers can our volume be here? So we really can plug in any number in the denominator except for 1, and that is 0. We can never have 0 in the denominator because we can't divide something by 0. And so we can just write here all real numbers excluding 0. And then for our range, then similarly, since we can plug in anything other than 0 for V, then we really can get anything out as our output, except for there's nothing we can divide by to equal 0, since 131 divided by any number will never equal 0. And so it's going to actually be the same as our domain, all real numbers excluding 0. And now let's go ahead and find our domain and range of our data set. So our domain is a very specific set of 5 numbers, 4 and 4/10, and then each value until 9. And so we can just write out those exact values. And then our range, similarly, is a specific set of 5 numbers. And so, starting with 29, we'll just go ahead and list those out. And so notice here that the domain and range, that's a discrete set of numbers, and they're subsets of our domain and range in the function model. And so now we have one last question to answer, and that is predict the pressure if the volume were 7 and 3/10 milliliters. And so we can go ahead and just plug in 7 and 3/10 for V, our volume, so P of 7 and 3/10. Then dividing those two, then we get 18.005, etc. A pretty long decimal. We'll just go ahead and round that off to 18 psi for pressure. And so there's our answer. We've covered all of the different questions, and so let's go ahead and summarize. The rational function P of V equals 131 and 44 hundredths divided by V, where 131 and 44 hundredths is the average of the products of V and P. The scatterplot and function graph indicate that the function P of V equals 131 and 44 hundredths divided by V is a reasonable model for the set of data because the graph of P of V follows the trend of the data by passing through or near the points in the scatterplot. The domain of the function P of V is all real numbers, excluding 0. The domain of the dataset contains the discrete values obtained in the experiment 4 and 4/10, 5, 6 and 2/10, 8 and 9/10, 9. This is a subset of the domain for the function model. The range of the function P of V is also all real numbers, excluding 0. The range of the dataset contains the discrete values obtained in the experiment 15, 16, 21, 26, 29, which is a subset of the range for the function model. The predicted pressure when the volume is 7 and 3/10 milliliters is 131 and 44 hundredths divided by 7 and 3/10, which equals 18 psi.